Welcome everyone. This is going to be our Algebra 2 Transformation Functions Lesson number 3, Vertical Stretching, Home Review Part 1. If you find these videos helpful, please give it a like and subscribe to the channel. And leave any questions or comments in the comments section below. Number 1. If the point -6, 10 lies in the graph of y equals f of x, then which of the following points must lie in the graph of y equals 1/2 f of x? So we find in this case when we're multiplying the function outside f of x, that's the same as a vertical stretch or compression. And so for that type of transformation, we'll see the following rule applied. We want to transform y equals f of x to y equals a f of x, a times f of x. We have vertical stretch compression. And basically the idea is that if a is greater than 1, it's going to be a vertical stretch. If a is between 0 and 1, then we'll have a compression. To transform the point f of x to a f of x, we keep the x value the same and multiply the y value by a. So it's the type of transformations are somewhat similar to dilation, but only for one aspect. Only the y value is being transformed, or in this case, multiplied by the constant. So we see -6, 10, and we're going to transform it by multiplying by 1/2 f of x. Therefore, since xy becomes x comma ay, and our a value here is 1/2, -6, 10 becomes -6, 1/2 times 10, or -6, 5, and that would be choice 3. Number 2, if the function h of x is defined as a vertical stretch by a factor of 2, followed by a reflection in the x-axis of the function f of x, then h of x is equal to? Okay, so we start off with f of x, and for a vertical stretch by a factor of 2, this now becomes 2 times f of x. Right? And now a reflection in the x-axis. Okay, so vertical stretch is always going to be multiplying the function outside. So whatever f of x is, multiply by that number. And then the reflection as x-axis means we're going to then multiply the whole thing by -1. So now we're multiplying 2f of x by -1. And so we get -2 f of x. And that would be choice 4. Number 3, if the graph of y equals 2x squared is compressed by a factor of 3 in the y direction, then shifted 4 units down, the resulting graph would have the equation of, okay. So when we're compressing, it means we're squishing in this case. So it would not, so the value of the number multiplying the function would not be greater than 1. Actually, it would be between 0 and 1. So a compressed by factor of 3 really means our a value is going to be 1/3. Okay? Because in this case, it's taking 1/3 of the height of the function. So the very first thing we'd do is x squared would then become 1/3 x squared. And from there it says, then shifted 4 units down. Well, a shift of 4 units down is a vertical shift, and it's outside the x value. So we would then take this 1/3 x squared and subtract it by 4 because we're doing 4 units down. So the resulting graph would be the equation 1/3 x squared minus 4, which looks like choice 1. Y equals 1/3 x squared minus 4. Number 4, the quadratic function f of x has a turning point at -3, 6. The quadratic y equals 2/3 f of x plus 3 would have a turning point of, well, let's take a look at transformation here. First, looking at 2/3 order operations, okay? If you're wondering what happens first, order operations means whatever's multiplying the function first is taken care of first. So we would have multiplying the function or vertical compression, okay, by multiplying the y value by 2/3. So the very first transformation would be xy becomes x comma 2/3 y. So that's the first thing we're going to do here. We're going to take our -3 comma 6, and then we'll keep -3, but multiply the 6 by 2/3. And 2/3 times 6 is actually 4, so we're going to get -3, -3, not -4, -3. But 2/3 of 6 is 4, so -3 comma 4. Now the next transformation would be adding 3 to the y value, because it's a vertical shift up by 3. So that would mean xy becomes x comma y plus 3. So we're going to take that -3 comma 4 and then make this into -3 comma 4 plus 3, which would give us -3 comma 7. And that's going to be the final point where the turning point is going to be after a vertical, really vertical compression, and we're multiplying the y value by a factor of 2/3. Right, so this would be a vertical compression. Really, if we were talking about compressions in this case, what's the value of the compression? It'd be the reciprocal of the number we see. So really, if we're multiplying by 2/3, it's really compression by 1.5 or 3/2. But the key thing to remember is that if we're trying to find the value of the coordinate afterwards, we're just going to multiply the y value by that number multiplying the function. So the answer is going to be choice 3. Question number 5. The function g of x is defined by g of x equals negative f of x plus 5. What 3 transformations have occurred in the graph of f to produce the graph of g? Specify both the transformations and their order. It was a really good question here. It's like very similar to what we had in our quiz. The very first thing we see we use order operations. So we see -5 multiplying. So in this case, when we see -5, really that's same as -1 times 5. This first number, -1, multiplying the function, because again, order operations, multiplication before addition. So -1 means first a reflection in the x-axis. Then we have the 5 here. And so here, this is a vertical stretch. Because multiplying here, vertical stretch, and the value in multiplying the function is greater than 1. Vertical stretch by a factor of 5. And now we have this last part here. So in this case, it was -5. So really, it's -5 f of x plus 4. So the plus 4 means at the very end, we're going to have a vertical shift. Up by 4 units. Okay? And that's it. And we use order operations to help us determine what numbers, which order goes which. Okay. Ladies and gentlemen, thanks so much for watching. This is going to be the end of our Algebra 2 Transformation of Functions, lesson number 3, Vertical Shifting Home Review, Part 1. Again, if you found any of this helpful, please give this video a like. It really helps with our channel. And of course, leave any questions or comments in the comment section below. And share this video if it's helpful. I'm doing our best. And if you found helpful and your friends need help and all, first off, try to help them out on your own. But always, in this case, if you're stuck and say, hey, I got this video I think you should watch, I appreciate it if you share with them. Okay, everybody? Thanks so much for watching. I'll see you in the next video. Take care and be safe.